Hello students. Hello and welcome to this video on determinants. We will solve question number 1 to 10. So there are a few things I would like to say is that determinants is really easy and it's a chapter where you can score compared to other chapters. It is relatively easy. Determinants and matrices both are relatively quite easy. So pay attention and do your best to learn more about determinants. The second thing is that the link of the PDFs will be in description, so you can download the PDFs. At the end, I will show you my website from where you can download all the PDFs, as well as I'll show you my question answer website where you can come and ask questions or give answers. So without further ado, let's get started. Question 1 says evaluate this determinant. First row is 497, 357 and 545. That is the determinant. Now the objective while you have to evaluate the determinant is to get as many zeros as possible. So we'll try to get as many zeros in the cells as possible. So what we do is we perform R1 is equal to R1 minus R2. So we subtract from R1 R2. So 4 minus 3 becomes 1, 9 minus 5 becomes 4, and 7 minus 7 becomes 0. Now you see that what we do here is that we do R2 minus R2 is equal to R2 minus 3 R1. Okay, R2 is equal to R2 minus 3 R1. So this is our R2 357, and we do minus 3 R1. So 3 minus 3 times 1 0. 5 times 4 times 5 minus 4 times 3, that is minus 7, and this remains 7 because it is 0. Then we do R3 is equal to R3 minus 5 R1. So we make this 5 0 as well. So 5 minus 5 times 1 0, and 4 minus 5 times 4 is minus 16, and this remains same because it is 0. So now we have two zeros here, so we can expand along the first column. So only one calculation we need to do, that is for this one. That will be minus 7 times 5 minus 16 times 7. So as you can see, it is 77, easy peasy. Okay. So that is how you achieve a maximum number of zeros, and then the calculation really becomes very easy. Question 2 says that show that the determinant 1a square, 1b square, 1c square is equal to a minus b times b minus c times c minus a. So here again we want as many zeros as possible. So what we do is from R1 we subtract R1 R2, that is R1 is equal to R1 minus R2, and R2 is equal to R2 minus R3. So it becomes 0, 1 minus 1 0, a minus b, a square minus b square, 0 b minus c, b square minus c square, and 1c c square. So from the first row we can take a minus b column, from the second row we can take b minus c column common. So outside we have a minus b times b minus c, and the determinant becomes 0 1 a plus b, 0 1 b plus c, 1 c c square. Now we will expand along the first column, and we need to calculate only for 1 because these two are 0. So this 1 becomes b plus c times 1 minus a minus b. So it becomes a minus b times b minus c times c minus a. Third question says that evaluate 1, 2, 4, 1, 3, 9, 1, 4, 16, making use of relations between second and third column. So we let a is equal to 2, b is equal to 3, c is equal to 4, then delta becomes 1a square, 1b b square, 1c c square. So it is similar to second problem now, and the answer would be 2 minus 3 into 3 minus 4 into 4 minus 2. That will be equal to 2. Just follow it like question 2 and you will have your answer. Question 4 says that evaluate 492, 357, 816. So what we do here is we do R1 is equal to R1 minus R2. So our R1 becomes 4 minus 3 1, 9 minus 5 4, and 2 minus 7 is minus 5, and the other two rows remain same. Then what we do, R2 is equal to R2 minus 3R1 and R3 is equal to R3 minus 5R1. So we have two zeros here and other things are also there. Then we expand along the first column, we get 46 times minus 7, that is minus 322, and this becomes plus 31 times 22, that is 682, and answer is 360. Question 5 says that evaluate 18 1 17, 22 3 19, and 26 5 21. So what we do here is we do R3 is equal to R3 minus R2. So this is our R3 and we subtract R2, so it becomes 422. And then we do R2 is equal to R2 minus R1. So this becomes 422 as well. Okay. So 26 minus 22, 4, 5 minus 3, 2, and 21 minus 19, 2. 22 minus 4, 18 is equal to 4, 3 minus 1, 2, and 19 minus 7, 2. So we have two identical rows and therefore the determinant value will be 0. Question 6 says that evaluate 497, 357, 545. So what we do is we do R1 is equal to R2 minus R1, or rather it should be R1 minus R2. Okay. So 4 minus 3 is 1, 9 minus 5 is 4, and 7 minus 7 is 0. So other two rows remain same. Now what we do the usual thing, R2 is equal to R2 minus 3 R1 and R3 is equal to R3 minus R1. Okay. So first row remains same and second row becomes 0 minus 7 7 and third row becomes 0 minus 16 5. And we expand along the first column, so we calculate only for 1, we get 77 as the answer. Question 7 says that evaluate 1 square, 2 square, 3 square, 2 square, 3 square, 4 square, 3 square, 4 square, 5 square. So we remove the squares, we get 149. And there seems to be something wrong here. Okay, this is 7, right? Okay, so what we do here is R3 is equal to R3 minus R2. So 9 minus 4, 5. Okay, and 16 minus 9 is 7, and 25 minus 16 is 9. So that is how we got 5, 7, and 9 as R3. Now we do R2 is equal to R2 minus R1. So 4 minus 1, 3. 9 minus 4 is 5 and 16 minus 9 is 7. So that's how we got 357. So we have this delta here after performing this operations. So then we subtract R3 is equal to R3 minus R2. We get 149, 357 and 222. Once we have 222, what we do is we do C3 is equal to C3 minus C2. That is column 3 we subtract from column 2. And column 2 we subtract from column 1. So we get two zeros here and 2 over here, and remaining operations you can see. Now we expand along the third row, so we evaluate only for 2 and we get minus 8 as the answer. Question 8 says that let ABC be positive and unequal, show that the value of the determinant ABC, BCA, CAB is negative. So what we do is we do column 1 is equal to column 1 plus column 2 plus column 3. We get A plus B in the first column. Another two columns remain same. We take out A plus B plus C. So we get 1 BC, 1 CA, 1 ABC, 1 AB. Now once we have that, what we do is we do R2 is equal to R2 minus R1. R2 is equal to R2 minus R1. So it becomes 0, C minus B, A minus C. And we do R3 is equal to R3 minus R1 also. So it becomes 0, A minus B, B minus C. Now once we do that, we have two zeros and we evaluate along the first column. So we do calculation for 1. So it becomes A plus B plus C times C minus B, that is this cell, times B minus C, minus A minus B times A minus C. So once you solve this, you will have minus half A plus B plus C times A minus B whole square plus B minus C whole square plus C minus A whole square. Now this sum will be always positive, okay? And A, B, C are positive, so this would be also positive. And therefore this leading sign of minus will be same. Okay, A, B, C are unequal, so this would be greater than 0. And that's how we have delta less than 0. Question 9 says that evaluate b plus c, a plus b, a, c plus a, b plus c, b, a plus b, c plus a, c. So once we have that, what we do is we do column 1 is equal to column 1 plus column 3. So we see that a plus b plus c can be taken out here. So the first column becomes a plus b plus c throughout, and second and third column remains unchanged. So we get a plus b plus c outside. We have this determinant, and once we have 1 1 1, what we can do is r2 is equal to r2 minus r1 and r3 is equal to r3 minus r1, and then we evaluate along this one, and we have a cube plus b cube plus c cube minus 3abc as the answer. So you can look at this calculation. Very simple trivial calculation for a class 12 student. Question 10 says that evaluate 1 plus a1, a2, a3, a1, 1 plus a2, a3, a1, a2, 1 plus a3. So again what we do is we do column 1 is equal to column 1 plus column 2 plus column 3. So our first column becomes 1 plus a1 plus a2 plus a3 throughout. Once we have that, we take that out. So we got first column entirely of 1s here. Once we have that, you know the exercise, we can do r1 is equal to r1 minus r2, r2 is equal to r2 minus r3 to get two zeros here in the first column, and this becomes minus 1, 0, 1 and minus 1. So once you have two zeros, we expand along the third, that is this, and we get the answer as 1 plus a1 plus a2 plus a3. Okay, so with this we come to the 10 questions of determinant. We come to the end of that. As you can see, the questions are relatively easy. Further questions will be slightly difficult, but rest assured that it will be still quite easy compared to other topics. Now I'll show you my website. So you can come to ashtavakra.org, which is my website. Second link, third link, and fourth links are maths books of algebra, trigonometry, and coordinate geometry. As you can see, this is the date on which it is updated. So coordinate geometry was updated today itself. You can click the link and download the PDF. The PDF will not have date, so you should add the date listed here to the PDF. And after 15-30 days, you can come back and check whether the book has been updated or not. And if it is updated, then you can download the latest one and add the date again. Also, coordinate geometry book has HTML format also. If you don't want to download the PDF, you can read the HTML one. And to read the HTML format, I would recommend Firefox browser because it uses MathML, and Firefox has best support for MathML. As far as I know, Chrome, Edge, and Safari also support MathML, but the support may not be as comprehensive as that of Firefox, and some rendering issue may be there. So personally, I use Firefox all the time, and it works very nicely. I have not seen any anomaly yet with MathML. Now the question answer website I was talking about is you can click the 8th link or come to kunjika.ashtavakra.org, make a login here, and you can ask questions of class 12 till algebra, calculus, geometry, coordinate geometry, mathematics if other tags do not satisfy your need, probability and trigonometry. And I should be able to answer your questions. That is if I know. And if you're an expert also, then you can join, and if somebody else asks questions, you can answer those questions. And if there will be more tags needed, I will add them as well. Don't worry about that. So this website I developed only for you guys so that you can come ahead and ask questions, because YouTube comments is not really suitable for question answer format. Like this determinant, you can't type in YouTube. Okay. That is just not possible. It will be mighty painful to draw these vertical bars. So with this, I will end this video here, and we will meet again tomorrow with 10 more problems and determinants. So till then, keep learning, stay curious, and most importantly, enjoy.